Hi students, welcome to this course, PLC Automation, an introduction to programmable logic controller. I am Professor Yao. Shift register applications. The keywords: a fraction moving arrow pattern, a PLC output terminal, one step at a time, one at a time. The International Distress Symbol, SOS, save our ship. Shift register applications. Figure 18.15 shows an arrangement of lights to give a fresh moving arrow pattern that moves to the right. Each light is connected to a PLC output terminal. Each terminal is controlled by a bit location in the two registers shown. As the bit patterns are moved to the right, one step at a time, the light pattern moved to the right. This picture shows the fraction arrow pattern and register. This picture shows the PLC program for the fraction arrow movement. The 7 ones in the register are progressively moved to the right and then up to the next register. Zeros are initially entered into the empty slot. As the bit moves, the light lamp pattern progressively moves to the right. In this system, a complete progress to the next arrow, example 1 through 7, does not move all at once. To 8 through 14, the lighted lamps progress to the next arrow, one at a time, starting at the top, 1, then 2, and etc. Figure 18.16 illustrates the complete PLC function that accomplished the movement. The speed of the movement is controlled by the time set in TT 0151, 5/10 of a second in this example. The SR register is therefore paused by the input shift line every 5/10 of a second by the timer. Enabling the timer, the SR is accomplished by in 0050. As the 1 moves through the register, the corresponding outputs are progressively turned on by the 28-bit peak functions, shown at the bottom. The arrow then moves to the right. To repeat the process, you could reload the zeros and ones manually by opening or closing the data line input, Or you could use the move system to reload the two operating registers from two master registers. Another possible reloaded system is to load from the output status. When the ones reach the end of the register, the shift right 0150 coils goes on for each step. This will cause a 1 to be reinserted into the initial slot. For a 0, the output is off, and a 0 will be reloaded. At the end of 31 steps, we are reloaded as shown. If you had used a rotate right function, the reloading would have been 32 automatic steps. The second example of the use of the shift register functions involved controlling a code output. The application involves using the SR or SL register, the output coil instead of the individual bits, for control and indicating. It uses the output as the Morse code indicator to light or buzzer. In the Morse code system, each letter is assigned a dot dash configuration and shown in figure 18.17. This picture shows the Morse code in SR register form. Follow the Morse code rules to put dots, dashes, and the intervals in the registers. A dot is 1 on bit wide, and a dash is 3 on bit wide. The resulting pattern for the international distress symbol SOS, save our ship, is put in input register holding register 51 and the holding register 52 in the figure. The bit pattern is then moved into two holding registers, 175 and 1676. The register bits are then shifted to the right to the output. The resulting output on-off pattern represents the code pattern. Figure 18.18 shows the PLC program to produce the code output. Turning on in 10 will move the complete coded pattern from the input register into two holding registers. This picture shows the Morse code shift register program. Turning on in 13 enables the SR functions and starts the pulsing timer. The timer contact in the SR shift line causes a bit to be inserted into the SR every 0.5 seconds. Since the timer is set at 0.5 of a second, a dot will be 0.5 seconds long, and a dash 3-bit 1.5 seconds long. Appropriate intervals are added between dot and dash. To speed up or slow down the rate code output, the timer time interval may be changed. Once the 32-bit have been shipped in, the message is over. We then have on or off signal for the output, depending on the SR data line setting during shifting. For the SOS, we must reload the holding register patterns into the IR register again and start over. An alternate to the reload procedure would be programming in a rotate right register system, which reloads continuously. Exercise 1. The keywords: set up a register control production line. Exercise 1. A product moved continuously down an assembly line that has 15 stations. Set up a register control production line for the pattern for product A only. The pattern is shown in figure 18.19. This picture shows the diagram for exercise 1 and 2. Exercise 2. The keywords: schedule, selector switch, design a PLC circuit. Exercise 2. 3 products are sent down a 15-station production line. They are product A of exercise 1 and product B and C. The schedule of which station are on or off for each of the 3 products is shown in figure 18.19. A selector switch is set according to which product is going down the production line. Design a PLC circuit to produce the 3 products to the required patterns. This is the diagram for exercise 1 and 2. Exercise 4. The keywords: take place sequentially, active or inactive, in reverse, assembly, disassembly. One assembly station produced 2 models of watches, E and F. 16 operations take place sequentially at the station. Stations are active or inactive depending on the model being produced. The station pattern is shown in figure 18.20. At the end of the day, all watches that have not passed the test or are disassembled by running the watch assembly operations in reverse. Design a PLC system with SR for assembly and SL for disassembly. Use the same pattern register for both the SR and SL functions. Diagram for exercise 4. Exercise 5. The keywords: clockwise rotation, rotating counterclockwise. Exercise 5. The lights in the circle are 8 degrees apart. The pattern of lighted lights is to rotate as shown in figure 18.21 in either direction. The 8-degree steps take place every 3 seconds for clockwise rotation. When pattern is rotated, counterclockwise steps are at 1 second intervals. Design a shift register system to accomplish this rotation. This picture shows diagram for exercise 5. Homework. Handwriting all keywords and submitting them to Coach Facebook. Just do the online quiz and see you next time.